Is the nucleus of 3I Atlas really 15 kilometers wide? The debate intensifies. Picture this. Astronomers believe they may have discovered a massive 15-kilometer-wide chunk of interstellar material barreling through our solar system. If true, 3I Atlas would dwarf previous visitors like 2I Borisov, and that's why scientists are buzzing. But here's the twist. Whether 3I Atlas's nucleus is really that gigantic isn't at all settled. Let's peel back the layers of evidence and controversy together. Recent observations from the powerful camera aboard the Zwicky Transient Facility, ZTF, have locked on to the interstellar object 3I Atlas since mid-May 2025, when it was still more than 6 times farther from the Sun than Earth is. It's been steadily brightening compared to what you'd expect from a non-active solid rock of a fixed size, especially noticeable from early June 2025 onward. This odds-defying glow points toward material, most likely icy debris, being expelled and scattering sunlight, a phenomenon vividly captured in a stunning Hubble Space Telescope image on July 21, 2025. Astoundingly, that glow stretches up to 10 times farther toward the Sun than away from it, suggesting the light likely comes from sunlit ice evaporating in dramatic fashion. And this is the part most people miss. If the object had been composed of dust and rock alone, we'd expect the solar wind to push the debris into a classic comet-like tail. But in the Hubble image, there's no such tail trailing behind. This detail hints that the mass loss is driven largely by ice sublimating in sunlight, not by dust. Yet, the story isn't so straightforward. Between May 15th and early June, the data reveal no change in the area reflecting sunlight, hinting at a curious plateau. The researchers compared this plateau to a computer model, which assumes 3I Atlas's nuclear core, the actual solid chunk at its center, is 5.6 kilometers wide. But let's be upfront. This is only an educated guess, entirely dependent on the chosen model and its assumptions. The ZTF observations consistently registered 5 to 10 times higher light flux than the model during this lull. But researchers caution that the margin of error is fairly wide at this early stage. Here's where the controversy heats up. What does this plateau really mean? The simplest case is that we're seeing the bare nucleus before it started shedding mass. If that's true, then the original nucleus would be larger by the square root of that brightness boost, making its real size about 15 kilometers in diameter. To put that in perspective, 3I Atlas would then be about 20 times the diameter and over 8,000 times the mass, assuming similar density, of 2I Borisov, the only other comparable interstellar comet detected so far. But wait! This sparks a huge question. If interstellar space is peppered with smaller objects like Borisov, why on Earth or in space did we spot such a whopper first? Does this mean gigantic interstellar travelers are far more common than we expected? Or is something skewing the odds in favor of a rare monster like 3I Atlas flying our way? Some argue the population of such colossi is vanishingly sparse, with only one expected to pass near the solar system every few thousand years. Others propose that 3I Atlas's peculiar approach, almost neatly aligned with the plane of the solar system, might not be just cosmic coincidence. Could its path be the result of some as yet unknown astrophysical process? Or even a result of deliberate technological manipulation? That's a bold leap, but it's being discussed. And you won't find everyone agreeing. Of course, given the sizable error margins in those early readings, it's possible, maybe even likely, that this nucleus size estimate is an overstatement and the real 3I atlas is much smaller. The coming months promise clarity. 3I Atlas's journey will bring it to within 29 million kilometers of Mars on October 3rd, 2025. This is the moment astronomers are waiting for. The high-rise camera aboard NASA's Mars Reconnaissance Orbiter will get a close shot with superb resolution. Thanks to the thin, see-through cometary cloud, scientists should get the best ever measurement of the nucleus size, up to 100 times more accurate than Hubble's best effort. It's like giving a detective a brand new magnifying glass to finally crack the case. Following the guiding wisdom of Sherlock Holmes, never leap to conclusions without evidence. And remember, the solution, however improbable, must be the one that remains. Astronomers are eagerly awaiting the images that could settle the debate for good. But what do you think? Are we witnessing the arrival of an interstellar giant, or is all this excitement just the result of tricky data and coincidental trajectories? Could there be more to these cosmic visitors than meets the eye, even down to artificial origins? Join the debate below. Are you a skeptic or ready to believe we've found something truly extraordinary? About the author, Avi Loeb leads the Galileo Project and founded the Black Hole Initiative at Harvard. He also directs the theoretical computation efforts at the Harvard-Smithsonian Center for Astrophysics and previously chaired Harvard's astronomy department. Loeb's voice in the scientific community stretches even into public policy, having served on the President's Council of Advisors on Science and Technology and the National Academy's Board on Physics and Astronomy. His best-selling books, including Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, and Interstellar, testify to his lifelong commitment to exploring the biggest cosmic questions.